Okay. So we were at this point yesterday. Pop quiz. What does MPL stand for, Sherman? Glad you all bailed him out because he didn't know. Did you, Sherman? Nice. Nice. Do you see the board for tomorrow, Sherman? Okay. All right. So the conclusion you had just reached as the bell was ringing is that as we added more labor, there was not more land. Yes, Connor?
Is it profit or
product? So you put more workers on less land, that makes each additional worker less productive than the worker before him, but overall increases productivity to a point, correct? Okay. So the MPL diminishes as your labor rises, whether the fixed input is land or capital. And remember, this isn't financial capital we're talking about factories, equipment, number of computers, number of cash registers, number of lawnmowers, whatever it is that you are using. Something is going to be in a fixed number. So as you increase your number of employees, your productivity per employee decreases. So it leaves us with diminishing marginal product. Diminishing marginal product. The marginal product produced by each input declines as the quantity of that input increases, ceteris paribus. Case in point, Bengston, Kavanaugh, why do we have swim practice in the morning and in the evening? There's only so many cubic feet of swimming pool in which to fit your swimmers. And if you try to put them all in there at the same time, how effective is the swim practice, Maddie? If we tried to put all the swimmers in the pool at the same time, how effective would the swim practice be? How many black eyes would there be? There would be a lot of black eyes. Okay? Black eyes. Black eyes. Yeah. Okay. Another thing to add to the list to enunciate properly. Okay, example. So Farmer Jack has to pay $1,000 a month for the land that he is leasing, regardless of how much wheat he grows. Fixed cost. He's going to pay his workers $2,000 a month. So, what do we know about Farmer Jack's costs? $1,000 fixed cost. What's his labor cost called? They're both explicit costs. But they're also related to how much wheat he produces, aren't they? That doesn't. Let me explain. I know. Let me explain. I didn't say how it was related. I said it's related. Just work. Okay? Regardless of how much he produces, how many bushels of wheat he produces, his land cost is fixed. His labor cost increases as his L increases, correct? Okay. So his total cost will increase. His total cost is related to his wheat production. Can we agree on that? Yes. Okay. So it's when you combine them. So if we graph it, What do you suppose this graph is going to look like off the top of your head? It's going to be a shoo as opposed to the shoo. Where do you suppose optimum is achieved? Where if we were graphing the where they meet. Oh! They aren't straight lines anymore. All right, marginal cost is the increase in total cost from producing one more unit. It is the change in total cost over the change in quantity. Thank you. Is this about too much response? Okay, you. When will we use marginal cost? To figure out what? Yeah, to figure out whether it's worth producing one more unit. Wouldn't it be nice if you could mathematically determine, is it worth me spending one more hour studying for my French test? I'm going to increase 0.3%. That's not worth it, right? Okay. So this is just like we previously calculated change in MPL, right? So the change in total cost from 1,000 to 3,000 is 2,000 change in total cost. The change in quantity is a change of 1,000. Do the division. Marginal cost is $2 for that next unit produced. Okay? To go from 0 bushels to 1,000 bushels, each additional bushel cost us $2. Yes, you should sell it above $2. Now, each additional bushel to go from 3,000 to 5,000 increases our total cost $2,000. Our quantity only increased by 800 when you do that math. Each additional bushel from 1,000 to 1,800 cost us $250. So on and so forth. 333. Whoop. I touched many things apparently here. There we are.
Oh, there he is, the man, the myth, legend,
Well, hello, Mr. Emmerich. Thank you, sir. Do you feel better now that you've been counseled? Okay. What is this curve going to look like, campers? Well, we know that marginal cost rises as Q rises, correct? Okay.
Which two axes are we graphing? Like, what's on
What do we always graph? What's always on the x-axis?
P and Q?
So what's our equivalent of P here? Marginal cost. So marginal cost will be on your y-axis. Right. So it's going to be very similar, just more extreme. So if you are a farmer, Jack, where do you stop producing more? Yeah, right about out the $5 level because to recoup the cost for producing those last, 200 bushels, that's very expensive wheat to sell and actually make a profit on, correct? Yep. So probably not worth it at that point. But what does that depend on? The price wheat is selling at. If I can sell the wheat for $20 a bushel, I'm going to hire somebody and grow that last 200 bushels on it. For sure. If I can only sell it at $6 a bushel. Right? It is a pretty big jump. And that's actually the way the world works. At a certain point, it's just not worth it to do them. I'm glad you asked. What would your optimal point be?
But you have to know the market price.
You do. You do. Okay. Farmer Jack is rational and wants to maximize his profit. So to increase profit, should he produce more or less wheat? This is often a startling idea. To make more money, to increase my profit, I should actually do less. That's entirely possible. Kavanaugh? We didn't have any half workers. I beg to differ. It is entirely possible for me as an employee to have 1.5 workers. It's called part-time. Well, I pay him full-time, but he only works half of the time he's there. Okay, so Farmer Jack has to think at the margin. Have I convinced you guys that you spend your lives thinking at the margin? You don't think about that first step in productivity. You think about the last point. Say what, Zach?
I just wonder why the farmer knows so much about margin.
Oh, farmers are actually very shrewd businessmen. If they weren't, they'd be homeless. Farmers have to be pretty well schooled in this stuff. Okay, if the cost of the additional wheat, which is our marginal cost, is less than the revenue he's going to get from selling it, less than that market price, his profits rise if he makes more. If the marginal cost is higher than, then he's going to lose money if he makes more. Okay. Fixed costs don't vary with the quantity of output produced. So, in our Farmer Jack example, what cost is fixed? The cost of his land is fixed. No matter how much he produces, he's paying $1,000 a month for that land. It's a fixed cost. You cannot vary your fixed costs. What fixed costs do we have in our everyday lives? Cost of housing. Your rent, your mortgage, whatever it is a fixed cost. If you have bought a car and are paying on it, or have lease payments on a car, that's a fixed cost. Max, you okay? You look like you're deep in thought. No?
He said that's not his birthday anymore.
Oh. Was it a good birthday though, Max?
It was indeed.
Good. Okay, variable costs change with the amount that you produce. So what is Farmer Jack's variable cost? Labor costs. Good. So for Farmer Jack, that is the wages that he pays out. What would be a variable cost for you?
Food.
Gas, to some extent food, to some extent electricity. How about number of MP3s produced? Extra jeans purchased? Right. Not necessarily luxuries, but things that you could do without or can alter or vary. You could go home and read a book by sunlight for a couple of hours after school instead of going home and turning the lights on and playing a video game while your computer is streaming a video. So you could decrease those electricity costs. And I know, I was watching. I activated your webcam.
So that means pretty close now.
Okay, so one example of his variable costs would be other materials. In Farmer Jack's situation, what might some of those other materials be? What? The seeds, fertilizer, irrigation, okay? Diesel fuel for the tractor. Insurance. Insurance is probably pretty close to a fixed cost. Okay, so total cost is fixed cost plus variable cost. Lots and lots and lots of abbreviations to learn in this chapter. Are you going to use them on the quiz? Oh yeah. Oh yeah. Oh yeah. I don't know. I'm not done writing it. And at this point, I feel like tomorrow will be a go over the end of chapter problems, and the quiz will be Thursday. But I reserve the right to revise that based upon where we get. Nice, Tony, nice. Okay, so we're going to leave Farmer Jack in the dust and look at some more generalized examples here, okay? This firm, we don't know what it is that they produce, but they have fixed costs of $100. They produce widgets, okay? Their variable costs are going to, so here's our fixed cost line. The variable costs increase not necessarily at a fixed rate, 70, 50, 40, 50, 70, 100, and what, 140? Okay. Okay. Got it? And so then total costs, how do we get that? Add them up. Add them up. And so there you go. So why did we do this? So that we can graph the marginal cost. I want you to look at how this table is set up. When you need to do this, this is the easiest way for you to set up your table. See how it's offset so that you're clearly putting the difference in? You do this in physics? Okay. All right. Marginal cost, again, is the change in total cost divided by the quantity change. Note this word right here, usually. Marginal cost rises as quantity rises due to diminishing marginal product. Instances where that doesn't happen are out there. For instance, right there. Sometimes marginal cost falls before it goes back up. Should you ever choose to operate at a point where marginal cost is still falling? No, you need to get at least to the bottom of that, or you're goofy and you're losing business, you're losing money. Okay? Sometimes marginal costs could be constant. For instance, if I have a robotic factory. A robot factory.
Are you making robots?
I have robots making robots. It's robotception. Oh, I'm in your head too, Bartels. All right. So we get a funky looking graph here when marginal costs decrease before they rise. Anybody remember how to calculate average fixed cost?
Total
Change
average
of
cost.
cost.
Total
Change
cost
in total
over.
cost over change in quantity.
Yeah. Ooh. That's what. Yeah.
No. It was a trick question. I haven't told you yet how to calculate average fixed cost. Do you suppose that it could be fixed cost over?
Trick questions aren't cool.
Well, you should have read the chapter.
I read half of it. It has since a fixed cost is the same as the check to you. It'll just be 100. Our fixed cost check always the same. What? No, since it's fixed, it will fixed cost of the change.
It's the fixed cost divided by the quantity. As the quantity is increasing, the average fixed costs had better go down if math. Since fixed costs are fixed and we're dividing by an ever-increasing quantity, my understanding of, I don't know, 4th grade math tells me that my result is going to be an increasingly decreasing number. An increasingly decreasing number?
At some point, will we put like all these graphs like on the same one that shows like where
Oh God, you hope not. That would be the ugliest, most difficult to read graph ever. We'll get to the point where I show you what you're doing with all of this. Just building blocks, Chpt. All right. This is a good situation. You want to spread those fixed costs over as much productivity as you can, right? If it costs Farmer Jack $1,000 to use his land, and he's leasing, say, 500 acres, does it make any sense for him to not farm all 500 acres he's paying for? Ceteris paribus, Kettleson. Yeah, you should use all of the land. This is like crazy old hermit rich people who have like a 17,000 square foot mansion and live in like 2 rooms of it. Their fixed costs are huge and their utility that they're gaining out of living in the 2 rooms is pretty low. Okay? This is like building the Trump Towers and choosing only to lease out 2 floors of it. You're not covering your costs. Okay? So you want to get your average fixed cost as low as you can. But you have to keep in mind the other costs that you have. Like your average variable cost. But it's simple math.
But it's so many different things you can confuse them.
But they're all logical. You can figure out how to calculate average fixed cost. Right? So your variable it's going to be your variable cost over quantity. So what have we got? We have an average variable cost that decreases and then increases, and that happens because our variable costs decrease and then increase. Okay? And so we get a nifty little smiley face. Yay. It's actually a laugher curve. That's hilarious. Yes? No.
But it's increasing by less.
Yeah, it increases by less, and then it increases by more. Okay. It actually looks like your braces, Michael. Do you guys have a list of about a dozen equations so far? I would encourage you to memorize these, or memorize how to figure them out.
Actually, all pretty consistent.
Yeah. So average total cost is total cost divided by quantity. Bet you never saw that coming.
You know one.
Simple math? Simple enough? Hey, focus. Questions on this? Simple enough? Simple-ish. I smell more math coming. If you add the averages, you get the average total cost. Or you can do the division. What's the point in showing you both of these equations? Because if you have already calculated total cost, just calculate your average total cost this way. If you haven't, if you've only done average fixed cost and average variable cost, calculate it this way. Why do more math that you don't have time to do? Because the exam and your quiz in here have end limits. You have to learn to manage your time. Do things efficiently. Okay, so we have a whole bunch of numbers in a very confusing looking chart, but you know how each column was calculated, correct? You could recreate this if necessary. You might.
That's just a lot of math. You have to do that 7 times.
Would you take fractions?
I would prefer decimals. Fractions are hard to graph. Average total cost is U-shaped. Average variable cost is smiley. Average fixed costs decrease. And your marginal cost goes up. Or Freddy Krueger got at it. There you go, Dashby. Oh, and guess what? You don't get colored pencils during the test. This is where, when you're graphing it, you don't try and make your graph as small as possible. Some of you really excel at trying to make the smallest possible graphs to read. You need to make it big and use a squiggly line for one, and a kind of wavy line for another, and a thin line for another, and a thick line. Okay? Figure out ways to do it. All right, practice time. You're going to need a sheet of scratch paper for this. Sherman?
So will we not have to figure out, like, which is fast? Like,
Oh, wait. I need to make sure you can figure out what's what first. Yes, of course you're going to have to evaluate. But before you can determine whether or not you like the car, you have to be able to drive it.
I like Audi R8s and I haven't driven one before.
So you don't know that you'd actually like one. Maybe the seat would be too long and cut into the backs of your knees.
That's true.
Or the armrest on this side would be too high and it would give you a stiff
I
neck.
have faith in those engineers. He'd get them custom made.
Those Germans, they don't know Tony. Is Audi German?
Yeah.
Okay.
They're Namibian.
Well, who's Swedish? Was it Volvo? Okay.
Koenigsegg.
Anybody having a hard time getting started?
No, still filling zero. I'm constructing the table.
What do you have to do first?
Take the 30 minus 80, so figure out the,
So what does that tell you?
at the fixed cost is 50.
That tells you your fixed cost. Because here, at 0, total cost was 50. That means it's your fixed cost. You're going to have no variable cost at 0 productivity. So that's going to be 0. Fixed cost is 50. You can confirm that when your variable cost is 30 and your total cost is still 80. A little logic. Remember way back when I told you this is one of the few classes where you actually have to think for yourself? Are you a believer now, Aaron? Don't be a believer. Be a hoker. So what's total cost at quantity 1? What do you suppose total cost at quantity 5 is? What should you do next? Well, go ahead and tackle the average fixed cost because that one's pretty easy, right? Okay, we know our fixed cost is 50, right? The equation for average variable cost is variable cost divided by quantity.
Oh, wow. Starting quick.
Huh? Am I getting too far ahead of you?
No, I can start now. Start in it now. Like for a second, I was like, wait.
So the relationship between marginal cost and total cost is what? If this is going over your head, I will be putting it up on YouTube so that you can come back and watch it and calculate it out. So now that you've done the mechanical part of this, the actual calculation, the math. What? Sort of. It's not exactly calculus, but the calculations of it.
It's more geometry, really.
I think it's biology. Spanish.
Okay. So, hey, come on. 10 more minutes. Stay focused.
Hey, focus.
Could you give us like a graph like that on the quiz?
Good. All right. Why is the ATC U-shaped? Why is average total cost U-shaped? Because the average fixed cost pull the average total cost down at first, and then as the average variable cost increases, then it pushes the average total cost back up. So where is the maximizing quantity?
So you use the lowest.
Use the lowest cost.
Alright, but at 6, you're making like, it's still more profit, isn't it?
How do you know what your profit is? You don't know anything about profit. You always want to get maximum quantity for lowest cost. So, at every point left of this intersection, every point left of where marginal costs intersect average total cost, what do we know? Average total cost is falling. When we're right of there, average total cost is rising. So, what's the conclusion? Where marginal cost crosses average total cost, that point is what? It's the ATC minimum. The optimal price? There's no price.
So is it only to be like the bottom of the average total cost?
Yeah. And so what this tells you is we thought that it was 5. It's actually just a little left of 5 because you have to graph the marginal cost in there to find where average total cost is the lowest. Should be.
But you can never be sure.
Okay. Now we said we're going to consider long run and short run. Oh yes. In the short run, there are always fixed costs. Your factory costs you just as much this month as it will 6 months from now as it will 6 years from now. Okay? That office space. In the long run, inputs become variable. They can increase in cost, they can decrease in cost, they can really mess with you. Read this and think. What are you laughing about? You were already reading it and thinking?
Yeah. I'm thinking all the time. That Kyle, he's a thinker.
Are you interested in maximizing your long run or your short run ATC? In the short run, you may have to absorb some losses, which I think we've talked about in a prior chapter, haven't we? About when sometimes it's necessary for a business to be sustainable in the long run to suffer through some hard times as it's getting started. You have to build up to achieve that maximization of ATC. Okay. You have 3 factory sizes to choose from. You can build a small, a medium, or a large factory. Okay. Each factory size has its own short-run average total cost curve. This is the average total cost curve of the small factory, average total cost of the medium factory, average total cost of the large factory. In the long run, we can change from one to the other to the other. But in the short run, you're building only one of these. Right? Well, but the average total cost of the small factory isn't much higher either. In fact, it and the large, but it's a much lower quantity at the same cost. And here you get a larger quantity at a lower cost, and still a larger quantity at a slightly higher cost, but essentially the same cost as in the small factory. You look at the intersections. It depends on how much you want to produce. How do you know how much you want to produce? If you look at the market, it tells you what quantity you can sell at the market price, right? So you have to look at the market to decide, do I want to produce this much? Do I want to produce this much? To produce quantity A, which factory are you going to build? Small or medium? Small. Correct. To produce anywhere in between, you're going to build your medium factory. And to produce at QB or anywhere higher, you're going to build the large. And again, how do you know which Q you want to produce? You look at the market for the good you're producing. I think I've exploded your minds enough for today. Work on those end of chapter problems. We'll push the quiz back to Thursday. Can I show you one more thing, though? It's a curve that's not a curve. The long run average total cost Got it? The long run average total cost is the continuation of all three of those. Because remember, in the short run you can only build one, in the long run you could go anywhere along there. Yeah, you're only going to produce at one point along this, but this shows you what your long run productive costs could be.